This video is a basic reminder of how coordinate geometry works in 2 dimensions. So in this question we have 2 coordinates, 2, 2 and 6, 1, and we've been asked to find the gradient of the line that passes through them. Always a good idea to do a sketch of the coordinates before you start working on them. So that's what I've got here. There's the 2, 2 and there's the 6, 1. Now gradient is given by the formula rise over run. How far the points have risen up and down the y-axis, and how far the points have run along up and down the x-axis. So in this case, if we calculate the rise, starting at A and travelling to B, always moving in the left to right direction, you've actually gone down 1 unit. So the rise is actually -1 here. And the run, we've gone from 2 to 6, so that's actually a run of 4. So that leaves us with a gradient of -1/4. So that's the answer to that. Find the equation of the line AB in the form y = mx plus c. Well, m is the gradient. So we know from the previous question we've got that. Now to find the equation we need to combine the gradient in the equation with one of the coordinates that we've been given. So we can put the gradient in place of the m, and now we're going to write the next line by replacing the y and the x with the points here. I'm going to choose this coordinate here, 2, 2, but I could just use 6, 1 as well. It would work just as well. So both the x and the y are both 2 in this case, so 2 equals -1/4 multiplied by 2, and I don't yet know what the c is. So I now quickly calculate this. I can use my calculator if I want, or in this case I don't think I need to. -1/4 multiplied by 2 is just -1/2 plus c. I need to find what the c is. I need to solve this simple equation by adding a half to both sides. So we're going to go to decimals now. 2.5 equals c. Now I can write the full equation. So I'm going to go back up here and I'm going to replace my m with -1/4. Y and x are in there as variables now because we haven't just got one coordinate, we've got an entire line. I now do know that c is 2.5. And you could have 5 over 2 here, you could have -0.25. That works fine. Fractions or decimals are acceptable. So we've got the equation, and we're now asked to do a sketch of the line. So in this course we're going to be focusing on using the graphics calculator to do this sort of thing. Now mine currently hasn't got any batteries in. I do have my computer screen version, which you can follow, but I warn you, because of the frame rate on the camera, there is a slightly disorientating effect, so just prepare yourself for this. Kind of cool. I'll try and focus on the camera in the center there. Okay, so when we're going to try and graph a equation like this, we're going to go to the graph menu. We're going to enter the graph equation, which in this case was y equals negative, and I'm going to use 0.25 here, slightly easier than putting the fraction in, using the x button here, plus 2.5, and that's it. I'm going to click on the draw option. Now we get this. Back to the question, which states that we want to sketch the line between -2 and 12 on the x-axis. So we can do that on the GDC by going to the view window, which is F3, and setting our x minimum to -2 and our maximum to 12, and then if we press enter and go back to draw, we're now going to get the sketch we want. So that's what we're actually going to produce when we sketch this graph. So you will see there's no numbers on there, but that is acceptable for the sketch. What we're also asked to do now, back to the paper, is find the value of y when x is 4.7 and also find the y-intercept. Well, again, we're going to look at the GDC in order to help us do that. So try and focus on this one in the center. There we go. Right, so there's our equation. Now, using the G-solve or graph solve menu here with F5, we can do a lot of different things. In the first question, we're trying to find the value of y when x is 4.7. So if we scroll across, we get this y calculation button. We can put in any x value we want, and it will tell us the y value. So if I put in the 4.7 we're given, press enter, it will highlight where that point is in the graph, and it will tell me that when x is 4.7, y is 1.325. So that is my answer. We were also asked to find the y-intercept. Well, you can actually read this off the equation, and it's just the c value here of 2.5. But if you weren't sure about that, you can also use the G-solve menu for that. There's actually an option here for y-intercept on F4, and then it will locate you there and tell you that y is 2.5. If you want to find the x-intercept, that's simply this point here, where the value for y would be 0. So for this one, we go to G-solve, we go across to an x calculation, and when the y is 0, what's the x going to be? Locates on this point, and it says that x is 10. And you can find a bunch of other points in a similar way on the GDC like that. So the questions I want you to do in preparation are these here. So finding the equation of these lines here, finding the equation of these lines here using the y equals mx plus c equation, and then these last three are quite similar to the ones that we were looking at in the video using the coordinates to find the gradient. I would also like you to sketch at least one of these on the GDC and just make sure you're comfortable with those calculator operations. In the lesson itself, we are going to look at some more complicated questions, starting with one like this. So there's a PDF of this on EduLink, so you don't have to read this now, but it is an applied question involving a city map that uses some of the same maths we just looked at. So you may want to look through this question first, and if you want to, you can bring the answer to the lesson, or you can just have a look through and think about how you might do that. Okay, good luck.